So next up, we're going to talk about continuous iterative development and deployment. I welcome to the stage Eileen and Hasan.
Which way am I going? Yeah, I don't know anything about that. Okay, that's us. Hi, thanks for joining us today. My name is Eileen Wrubel. I lead the Continuous Lifecycle Solutions Initiative here at the SEI. We help government and defense organizations apply innovative software systems and software and systems engineering approaches and acquisition approaches that leverage Agile and Lean principles. We also help remove systemic barriers to adoption of Agile and Lean approaches.
Hi, I'm Hasan Yasar. I'm the technical manager of the Secure Lifecycle Solution in the 3rd Division in this SEI. First, I'm working very closely with the Agile team and making a DevOps reality and using principles of Agiles. And also, I'm teaching at the DevOps class with Lambert. He's in here as well. It was the first class in 2015 as academia, so we are teaching a graduate level. And at the same time, helping with the DoD as a team to adapt the DevOps technologies and principles, what we learn from industry and how the DoD is different, how can we help adapt the DevOps technologies and principles in DoD.
So our two teams collaborate extensively to help government and defense organizations apply Agile, Lean, and DevOps principles and practices to address those 4 enduring challenges that we've been hearing about today. So in our time with you, Hasan and I are going to talk a little bit about the landscape that we operate in. We'll bring you 3 experience reports from programs that we've worked with in various mission contexts and various phases of acquisition to apply these principles to meet those challenges. And then, as you know, as we work with our client and partner programs, we identify hard problems that merit additional research. So we'll close out by introducing you to 2 of the research efforts that are related to this work. Everything that we do in Agile, Lean, and DevOps is about buying down risk. So if you think about getting lost on your way to anywhere, none of us want to ask for directions anymore. The further we get from validating where we are, the more likely we are to incur catastrophic results of mistakes that we've made. So this is all about engaging in fast feedback cycles. We get continuous opportunities to reach out to our users, our end user community, our stakeholders, to get continuous validation that we have built the right thing. Those frequent checkpoints make sure that when we need to make course corrections, because it's going to happen, sometimes we get it wrong, sometimes there are changes in the environment, we're never too far off from the last time that we checkpointed ourselves. This also enables us to engage in continuous verification, make sure that the right thing that we built works as we intended.
So our objective is really help the DoD as an outcome and get an automated software development lifecycle and in either the process-wise and acquisition-wise to build a highly assured software and addressing any vulnerabilities, any problems early lifecycle by using the continuous iterative development practices, which is basically in DevOps. We would like to make that happen because if you look at the previous things Eileen, she mentioned about the risks, and goal is to get the risk early addressed in early life cycle. To do that, it is really requiring automation techniques. It is requiring the principles of DevOps. It's requiring tooling aspect of it. So all these things is requiring a lot of testing as well, because if you are doing the risk, if you are looking for any type of vulnerabilities, any type of testing, we have to look at what is things, and we can do the more testing throughout the life cycle. But before that, really, we have to understand why is this DoD is different than the commercial, because we cannot really take the known principles on the AWS or Amazon or Google, take their DevOps approach and adapt to in DoD. There's no way. So let's take a look why DoD is different, right? First things is DoD is different because DoD depends on the software, and I'm sure everybody is in the same area with me. We're really not developing a software from the scratch. We do some sort of it. We have internal development activities, but mainly we are acquiring the software. So when we acquire the software and we are getting requirements, kind of writing very like a tick documentation about the requirements, most likely we are doing the more waterfall approach and acquiring all these things, which when we have the software in our environment and we are responsible as a DoD maintain the software, like we are responsible for addressing any vulnerabilities, we are responsible for anything about the maintain the application, and we are kind of in a sustainment phase. So if you find any problems in this, the life cycle, like we just saw, and then it takes time to go back and fix it. Some of them requiring architectural changes. Some of the vulnerabilities, it's requiring a big changes in the life cycle and the application components, which is costing so much money for us, right? So that means we have to get the modern software development practices into the life cycle. But it's not that easy. I'm sure everybody's agree with me. So let's talk about what type of challenges we are having it, right? So I kind of like it's a long list. We don't want to put everything in the list. There's many risks it's available. There's so many challenges. First of all, let's look at how the Amazon or Google, I'm sure I'm hearing, because when I go any DoD the site and hearing like, hey, Amazon does the millisecond deployment, can I do the same thing? No, we don't do that because our system is different. Our requirements is different in terms of we have a different risks. We have a systems of systems. As Roman mentioned this morning, we have a different type of systems. You cannot really get a webby approach and like a completely architecturally designed based on the web component, microservice and stuff, get into the DoD system. So it's not that easy. It's difficult, requiring more challenge to fix it, maybe architectural things, maybe cultural stuff. So another things also in the DevOps domain, it's ruthlessly, everything's automated. Can we do everything is automated in DoD software, DoD acquisition, or DoD systems? We cannot. Some of those things, yes, we have the automation. Some of the testing we should, but do we have to do automation, everything in a hardware-based system? How much we can do? And how much we can do testing if the testing depends on kind of affecting the life of the person, like soldiers? And can we do the kind of like missile testing automation? We cannot. However, we can take some principles of DevOps components, which we're going to talk about on the road, how much we can take the principles of DevOps, maybe other components, and try to adapt to DevOps by knowing the risks, by knowing the challenges, what we are having it. So there are other things also like cultural challenges as well in DoD. So I'm just going to share the one quick notes here. And I'm sure everyone knows the waterfall approach, right? Waterfall papers, it's written in 1971. So waterfall paper was actually saying we have to have iterative development activities, but as a DoD, we took that approach. We created a siloed, creating a group of people, an architecting group and design group and development group. So we ended up taking a waterfall, making it a more siloed thing, so which is a cultural elements we are seeing it so far. And in some example, I will share it. And they were able to do more DevOps because they were able to overcome the challenges as a cultural challenges, change the mindset, and make DevOps available.
So everything that we're talking about with engaging in these fast learning cycles is enabled by things like taking advantage of the flexibility that's already available in acquisition policy and guidance. There is a lot out there that helps us be nimble in responding to and working with contractors and collaborators. We focus on small batches, whatever that means in context, but doing small pieces of work that are relatively easily bound that give us the opportunity for regular delivery and demonstration. Ritwik talked earlier about the benefits of cross-functional teaming, and that's something that we emphasize here as well. That helps us build generalists who can solve problems in different ways. That helps us push testing further to the left by embedding testing activities in engineering teams in order to get that regular feedback, that constant verification and validation. So I'm going to move us on now. So why are we here? All of this is about putting capability in the hands of our users and the people who depend on what we provide when they need it. Not 5 years later, not 7 years later, not 2 years late to need. We're about adaptation to environmental change and exploitation of variability in the environment. A lot of us came out of environment, we come out of backgrounds where we're taught that variability is bad, right? We want to stamp out any kind of perturbations. We also, a lot of us grew up in an acquisition community where we were taught that changes in requirements are bad. Everybody seen the Pentagon Wars? Anybody? Okay, right. That's not the kind of stuff I'm talking about here, but when we talk about Agile, Lean, and DevOps, and when we talk about baselining at the capability level and pushing decision-making down, a lot of people see that movie playing in their heads, and that's not what we're after. we need to be able to respond to new vulnerabilities quickly. We need to be able to anticipate the needs of the warfighter in the face of a changing threat environment. And we need to be able to take advantage of technological innovation. There are things that are great things that are going to happen that we didn't know about a year ago. We want to use them now while they're fresh and not put them in somebody's hands 8 years from now. This is why we do what we do.
So when you look at the DevOps, I mean, since this morning, I kind of counted how many times we heard DevOps from the speakers. It's more than 10 times. Yeah. So I felt I was correct because I thought I'm going to put this DevOps definition or not, but I said I should do it. Because there are many definitions of DevOps, and I really would like to set the stage what DevOps it is. DevOps is not a tool. It is not just the one component. It is the set of practices and also the principles that is really helping for communicate and collaborate all the stakeholders. It looks like a DevOps, but it is not. So all the stakeholders are in the life cycle of application life cycle, from acquisition departments and architect people, designers, and information assurances. Whoever has a right to say something in application life cycle, that has to be communicated amongst the team members. That's one principle of DevOps we should have. So a couple other principles it's important to adapt to DevOps. One is the collaboration and communication pieces. That's helping the people to communicate each other, which is what Agile is talking as well. So we have to let them to communicate and to collaborate with all the stakeholders, all responsible parties, including end users, including acquisition people. It's not that easy. It is requiring a proper platform. It's requiring infrastructure pieces and stuff. So the next one is infrastructure as code, which is we heard about automations. So automation is requiring some component which you have to write. Nothing happens magically by itself. There is no such magic. I know we are talking about automation as magic, but there is a work behind it. So work is basically using infrastructure code as a DevOps perspective, like writing everything, and everything has to be code. Everything has to be code. Either the configuration, either the changing component in the system, or the artifacts, whatever you're doing in the application lifecycle has to be scripted because infrastructure code, kind of like a building the road first and with the right people. And after that is the next one is the automation. So once you have a proper pipeline, once you have the proper people change the mindset, you can automation on top of it. So using the right tools and writing the scripts that makes you to do the continuous testings or the verification or name it for any possible manual activities, you can automate it. The next one is the monitoring. So you have to really monitor yourself and organizationally, program-wise, where are we? Are we on the right track? Are we developing the right software? Are we in the right testings? What is our quality attributes of the software in terms of security, in terms of all name it, any reliability, security, all the things. That is kind of our monitoring perspective. So when we talk about the benefits of DevOps, again, I don't want to list, it's a long list, but a couple of things I would like to highlight here is what is the DevOps is bringing. That's how the business is driven so much in industry. It is automation, of which we heard about it. It is reducing any errors in the life cycle, which makes it easy to capture any errors in the life cycle. Like if you have a fully Agile and a DevOps, you're easily able to get an error in the day one if you have a continuous integration. Versus if you have a monolithic approach, if you're doing testing towards at the end, you may get captured errors maybe 6 months later. If you captured any errors early, you are saving a lot of money and time because you're able to capture that on component like at day one. And then other things also, it's very important psychologically and developer perspective. So developers are spending typically more time, not writing a code actually. They're spending more time for understanding the knowledge or transferring information to program manager and more about the nonsense of the work. It is required, but it's really repeating things like giving a feedback to the program manager, giving the feedback where we are in terms of the tasking. So developer really not spending time for actual writing a code. And based on what we see in industry, and probably we would like to see in the audience as well specifically, if anybody is using a DevOps adaptation, they're able to increase the 40% of time for innovating the new things, like spending more time for quality attributes of the code, spending more time understanding and improving themselves for new technologies, adapting themselves for and getting new techniques and improving the software quality by using these principles. Right? So as the SEI said, let's have something like a model to show one graph that has everything in it, which is DevOps Factory. So it's this community is going more about automation, right? So automation is really getting from the features, think about the factors, so engine is running behind the scene, all engine is basically CI and CD, continuous integration, continuous deployment, continuous delivery, running behind the scene. So think about everything's automated, but actually we are doing the typical SDLC in every phases, every iterations. Like if you have a 3-week sprint or 2-week sprint, still we do some iteration of the work, right? So starting from features, we are doing the architecture, we are doing the design and testing and deployment and development, testing and deployment. So we do all these activities. So misunderstanding what I heard so far in the DoD, it looks like we are against architecture. No, DevOps is not against architecture actually. It is helping to build up the right architecture, but not a monolithic architecture, having a feature-specific architecture, feature-specific deployment and design and testing. So that makes it really easy to build up the overall factory idea and have all the stakeholders are seeing it. Seeing it means like not actually, think about a factory, seeing the result coming from the pipeline. So result can come through the continuous feedback, right? Result can produce from the CI server, like maybe report, maybe chat, maybe some message. Like some organizations are perfectly able to use the chat capabilities, like getting a message from the CI server says, hey, I broke the build. Who really broke the build? What is the cause of that build problems? Getting direct message to the users or developers, and they have see what's going on with the pipeline, they can go easily fix it. Or creating a ticket directly, and same thing for security components. Like if we know what type of vulnerability we have, what type of testing we have done it so far, get feedback directly to the stakeholder, like a security folks, architect, and immediately, because feedback should be on time. If we have a feedback on time, so we can easily address that any type of known things right away.
Okay, so let's talk about some cool stuff we did with partner programs to apply these principles and techniques to help them deliver timely, affordable, trustworthy, software-enabled capability. I know we have some folks from NASA in the house, a few folks from NASA IV&V. We had the privilege of working with the folks at the Orion IV&V program. Orion Multipurpose Crew Vehicle is NASA's next human-rated spacecraft, so I think we can all agree that that's a big safety critical deal. And the professionals at IV&V support the software composition by, they assess untrusted components, and they provide assurance that, against risk that software will not prevent the successful and safe execution of the mission. And I'm talking at a very high level here. Previously, what these folks did was they looked at entire entities, things like guidance, navigation, and control, electrical and video. They prioritized them to assess risk, and then they basically were able to provide that kind of assurance feedback on a schedule that operated about twice a year. They realized that they were out of sync with the speed at which the software engineering organization was delivering mission capability, and they wanted to correct that and get the feedback closer and targeted more on point to what was being delivered. So as the SEI started to partner with them, they started down this approach called following the risk, where they looked at, instead of these big high-level entities, they really started focusing on mission capabilities regardless of their relationship to those individual entities. And by streamlining that work and prioritizing those capabilities dynamically on a regular basis, more in cadence with the software delivery, they were able to be much more responsive and provide feedback that was much more in sync with what was going on in the software. So nobody was waiting 6 months to find out that something was perceived as high risk. They were basically able to change the flow of that communication to be more effective and down to a matter of weeks instead of a matter of months. And then they did this really cool thing. They built this heat map. So what you're looking at is a static representation that lets them drill down. And at any given point, that's IV&V's perspective on risk for various mission capabilities. And so all of the stakeholders have access to that. It's a very clear indicator. They can drill down into that. And then if something was green and turns red, for example, they can talk about that in real time and continue to progress and make more timely informed decisions. This is informing all of the work that we are doing with various programs and various aspects of IV&V. Our next experience report is from a program office that won't be named, but they really wanted to sort of eat their own dog food. They had a contractor that was using Agile and Lean software engineering approaches, And they wanted to apply those same kinds of principles to the way the program office was engaging with the developer. And this was for a couple of reasons. They realized that they had bottlenecks and ways to improve their own responsiveness, but they really wanted to understand the challenges that the contractor was facing and be a better collaborator. They figured they'd be able to identify their bottlenecks, make more timely decisions, have some added benefits like making it easier to onboard their new active duty staff, and the results were pretty mind-blowing. This all happened within a very short time period. We're talking 75 to 85% reductions in schedule for critical activities such as technical evaluations, and adding complexity to the mission. So they were able to respond much more dynamically to the contractor, make better informed decisions that led to adding capability to the mission in a shorter amount of time, which translates into real dollars somewhere along the way, right? And then they were able to deliver early in order to help another organization meet its mission need. So we all thought that was pretty cool. They used a combination of cloud-based tools. Many of you are familiar with Jira and Confluence. They used those to organize the work that they were executing and centralize documentation and decision-making practices and policies. They effectively built themselves a DevOps pipeline for the activities of organizing and managing the acquisition tasks, improve visibility all the way down. This work, we piloted some workshop and some techniques with this program that we are rolling out to other client programs and working to make more available through our other transition mechanisms on a broad basis to the DoD and larger community.
So next example I'm going to share with the JIDO, getting their permission. Mr. Filio Garcia is the CTO of JIDO, so he gave me the permission to use his graphics. So it's evolving. As an SCI, we had a work relationship with them. And what they set it up as secure DevOps pipeline, SecDevOps pipeline, and they were able to have 80 in a day using this magic pipeline. It's not a magic, again. We are hearing about it, but it's all about using a right process and then using the right tooling at the moment. So what they did at JIDO, and they changed that and adapt the architecture component first and changing the policies and procedures, how they are doing the features. So they adapted the Agile Scrum. They have a daily Agile meetings and they get together, identify what type of task has to be done. So there's a different color here. So the color is about the human interaction and automations and other information resource pieces. So getting a process and having an agile process daily, and then putting a task into the Jira ticketing system and developing a right secure testing, so they will get ATO in a day by using the DevOps tools and techniques. So what they did, so behind the scene, actually, they did automation heavily. So they used the CI, continuous integration, continuous deployment, continuous delivery. So they used the requirements from RMF. Anybody read RMF 800-37? So that's basically 6 steps in it. It is recommending have automation to adapt to really address any type of RMF categorization risks. So the secret sauce behind it is automation, but they were able to chunk any type of requirements, security requirements, as part of the task, and able to write the test cases for each requirements and run through the CI server, get the feedback, so information assurance person knows, and the testing is done, so they can validate it, they can verify it, so have an assurances in the systems, and they can approve the application that goes into the production or the staging environment, which is a full transparency, but full traceable throughout the life cycle. So looking for overall perspective, which we kind of shared a minute ago, and addressing security in every phases of life cycle, not at the end, not just doing the static analysis only on the code basis, but tying into all the security activities throughout the life cycle and collect the data on every phases of development phase and get back data into the security folks. So information assurance person knows what the requirements it is, and also sometimes they are setting up the requirements in terms of the environment-wise. They were able to say, here is the right Linux version, either Ubuntu or Red Hat, you have to use it from day number 1 as soon as when the project starts, which is giving environment parity and easily right away, so information has high degree of accepting the work and then continue.
Okay, so let's talk a little bit about cool problems that we're seeing all over the work that we're doing with DoD and government organizations. We are doing more work with measurement. If everybody's using Agile and Lean and DevOps approaches, what does it mean to say, how much does it cost to deliver a capability? How do we decide if it was worth it in the end? What's the difference when we're talking about an airplane versus a defense business system versus a cyber platform that only serves as as leverage for other capability? We're doing a lot of that right now. We are exploring what does it mean to build a SecDevOps pipeline in the context of a safety critical system. We talked a little bit in the experience reports about organizational agility, and we know that it's not just about the program office and it's not just about the software engineering, but we need agility across the ecosystem with all of the stakeholders if we're going to take Agile out of the space at the bottom of the system engineering V and really be able to deliver capability at a sustainable pace consistently when the warfighter needs it. That feeds into the work that we are doing in IV&V in various contexts. And then let's not forget about the fact that we are working with extremely long-lasting systems, lots of legacy code, lots of legacy monolithic architectures. What does it mean to stand up a DevOps pipeline? What does it mean to do iterative software engineering when we're in an environment like that? And Hasan's going to talk about two of the related research efforts.
So the first one is, actually you can find all the two research the write-ups in your booklet, which we are sharing. And first one is how can we really help the DoD for migrating legacy systems into the cloud environment. So as a research proposal, it's really challenging either taking existing system, either rebuilding or taking as it is and putting the cloud. And one of the techniques, we thought it's very helpful using infrastructure code pieces to help legacy systems move into the cloud. Why is that? Because typically when we acquire the software and remember the challenges, we're not really asking the deployment or the build environment. We typically acquire the binaries and putting the binaries in the working environment. It's just working. As long as it is working, we're not worrying about it. Now, when you move into the cloud, now we have to really move that environment, it's a running system into the cloud. So how are we going to find out the dependencies? And what type of dependencies or hierarchy that server or migration system, the legacy system has it. So the solution-wise, we use the infrastructure code pieces, basic understanding the system, dependencies, understanding the libraries is being used, and try to replicate that environment by crawling, kind of like doing the reverse engineering on the deployment of application, understanding that as the writing a script and use that components put into the cloud environment. Ideally, so even you develop an IAC properly, you may not depend on the one cloud, you may have an abstracted version of the deployment, you may be able to use a multiple cloud environment if it is necessary. So not in the single version. Another research, we were working on it, and Rick Hasman is here as well. So it's basically the side effect of the DevOps, I'm calling that way because I know there's a side effect, right? Because there's DevOps is, we said, more open source, more tooling. However, with almost every software right now, it depends on the libraries from the open source community. How much we can trust open source community or the libraries. So as a research, we're looking for to build up some sort of confidence level of the dependencies or the libraries and help a developer to use that tools properly by knowing what type of tools they were using it, give them a score, give them some indicators. Yes, I use that libraries, I have a confidence on that libraries, I'm monitoring it, I can use that. So as a solution, we are developing a scorecard approach for the two perspectives. One is the project health perspective, other one is the quality attribute indicator. Looking for two perspective, developing some mathematical formula, like basically giving a score of the licensing of the CVs for that libraries, and build up the knowledge, build up the confidence of that components, and then so we can put in our application lifecycle. It's a really challenging problem. The biggest problem is and how we can trust it, how can we validate that open source, because it's growing. And adversaries are taking advantage of the DevOps automation. They're inserting a lot of malicious activities into the DevOps pipeline by using the open source libraries, like by using the automation of this continuous integration or continuous delivery, continuous deployment. So we have to be aware of these side effects, and as in terms of be ready, we have to use it, but we have to be ready what type of things we are seeing it as part of DevOps pipeline. So okay. Next things.
So how do we make all this great stuff the new normal? This is an example, this is a set of examples of some of the things the SEI is doing to really push all of these Agile, Lean, DevOps principles and practices, these things that we're doing, into the state of the practice in the government and DoD. We do a variety of outreach. We're at the same conferences that you go to. We teach, we have all the webinars, we do all this great stuff. We build bridges between the DoD, the government, and industry through building communities of practice, through sponsoring, hosting, speaking at, taking leadership roles in prominent events in the industry so that we can foster those kinds of conversations in the environment. And we also work to inform policy and other guidance that comes out of the DoD and federal government. We've partnered with Defense Acquisition University for a number of years on various aspects of their curriculum in applying Agile, Lean, and DevOps to the lessons that the acquisition workforce needs to learn. We've worked with the GAO. Hasan is working on the IEEE DevOps standard. So we are out there on a number of fronts, really trying to push this into the state of the practice. You don't have to read this slide, it's okay. These are two examples that are in the slides that you're going to get that show how we are leveraging aspects of the acquisition system, commercial lessons learned and best practices, and Agile and Lean, DevOps and principles to help our client programs address those 4 enduring challenges. So those are left there for you as illustrations. You can learn more, again, this is all in the slides. You can come visit us on the SEI website. You know, listen to a podcast or two. You'll see me a lot. You'll see Hasan and I doing webinars. And finally, these are some of the talented professionals that make this all go. We all love doing this work. This is the most fun we've ever had. So please engage with us.
It's a team effort. So it's really a great team effort. And one thing is DevOps and Agile has to be team effort. It's not a single instance. It has to be work together.
Yeah. Great. And with that, I think we still have some time for questions.
Yes, so. Absolutely.
I know that I'm Alex Boydston from the Army, work on the Joint Multi-Role Program for Future Vertical Lift. I know the various services have the material release processes. We have a material release process. Have you looked at that to see all of the different things that you have to do in order to get a material release for a system? Because that plays into this whole process for applying DevOps to the acceptance of our systems.
We're working with a number of embedded weapons systems programs now, and so that's part of the universe on each one of those engagements. I don't have an encapsulated answer for you, except that on a case-by-case basis, we are interacting with those functions in the development and deployment of systems.
Yeah, a part of that is, from our perspective, and I know that Navy and Air Force also face this, the airworthiness release process that we have to go through. Typically, at minimum, we're facing an 18-month cycle there, if not longer, to get through those processes. In order to improve that, whether we're going for an ATO for security or for an airworthiness release, there's definitely some challenges that need to be attacked.
Right. So part of that is so you talked about ATOs and you talked about airworthiness. Part of that is building the information needs to support those processes into the life cycle on a continuous basis. DevOps helps us do that, helps us maintain that, build that body of evidence.
It may not be direct answer, but however, I can suggest one thing. When I said infrastructure as a code, is kind of keeping all the artifacts as a repository. Think about the same thing for documentation, for any information you're collecting. And it has to be treated as a code and keep in the repository. So we wrote, as an essay, we wrote a paper like, how can we automate the document creation as part of the CI server? So if you kept that artifacts as the traceable, and also if you're able to diff the artifact as part of your application lifecycle, there is a way you can improve the process-wise. You can say only differences and you get approval, not everything else has been done. So give that, not really having a more local approval process for anything, it's like having incremental. So basically, the one thing I would like to specifically say that Agile and DevOps is not against for documentation. It is not. But you have to take that concept, put into the application lifecycle as a code, treat as a code, and put into the repositories.
Right. So part of the things that we're looking at is the possibility of having a repository, cloud-based repository that would contain the software, the related artifacts that go with that, including qualification artifacts, so that you've got a certain pedigree for that software to be integrated into the system.
Right.
Exactly. This also speaks to, since you're there, I'm going to tack on, this also speaks to what we talked about earlier about organizational agility. Getting those stakeholders engaged on a consistent basis throughout the life cycle is a really important part of solving the problem that you're asking about.
Thank you.
Any more? Any more questions? Great.
Yes. Wow. Okay, so just to set the stage for those who aren't familiar with the situation, in 2016, my colleague Will Hayes, who's sitting in the front there, say hi, Will. Will testified in front of the House Ways and Means Subcommittee on Social Security about applying Agile and Lean approaches in the context of the modernization issues the Social Security Administration was facing. We do also, when asked, provide information to meet the needs of various other stakeholders. I'd like to think that we are part of a community that has been able to educate stakeholders, who make policy and legislation about how we can really go about applying iterative and lean and DevOps kinds of approaches. But I won't. I'd like to believe that we are successful, but I won't try to read anybody's mind about exactly how big a part of that we were. But I'd like to believe we are part of a broad landscape of contributors there.
Any more questions?
Everybody wants coffee.
I guess so. We'll be here, and if anybody has a
here.
specific question, how we can do it in the technical details, I'm willing to talk more into the technical details on DevOps and adaptation things. Thank you so much.
Thank you, Eileen. Thank you, Hasan.